Today we're going to be talking about multiplying exponents, and we are going to continue on with our process of exponents for a few more lessons. So let's jump right in. First of all, we're given the expression 2 to the second times 2 to the third power. We are going to go ahead and write that out as repeated factors. In other words, how would we write out 2 to the second? Well, hopefully you will recall that when we have an exponent of 2, that tells us that we're going to multiply our base times itself 2 times. And when we have an exponent of 3, it tells us that we're going to multiply this base by itself 3 times. So if I'm going to go ahead and write that out as in repeated factors, it'll look like this. 2 times 2 times 2 times 2 times 2. But that's not what the answer is looking for. The answer is looking for a single exponent. So if we need that as a single exponent, first thing we look at is what is the number being multiplied over and over again by itself. And that number is 2. So that becomes our base. Our base will be 2. How many times it's being multiplied by itself is our exponent. So we know we have 1, 2, 3, 4, 5. So this actually becomes 2 to the 5th power. And I'm going to go ahead and bring that up. 2 to the 5th power. Good. I'm glad that worked. Now let's look at this one, our second example. This 2 tells us we're going to write 3 times 3. This 2 tells us we're going to write it out as 3 times 3. So as repeated factors, it will look like this. 3 times 3 times 3 times 3. Well, once again, what is the number being multiplied over and over again? That's the number 3. That becomes our base. And then the exponent is how many times are we multiplying that number times itself? 1, 2, 3, 4. So the exponent would be 4. So if we're going to write that as a single exponent, it will look like 3 to the 4th power. Beautiful. Let's look at this last one. Remember, the 2 tells us to write out the negative 2 as my base 2 times itself. So we have negative 2. And remember, if it starts with parentheses, it has to continue with parentheses because that parentheses keeps the negative and the 2 together. And then this 4 here tells us to write out negative 2 times itself 4 times. So 1, 2, 3. Hopefully yours is a little bit messy or neater than mine, not messier. Oh gee, not messier. And 4. There it is. So remember, our base is that number being multiplied times itself over and over again. So in this situation, it's a negative 2. Keep those parentheses around that to show that the negative and the 2 go together as the base. And we're multiplying it times itself. 1, 2, 3, 4, 5, 6. So that will be negative 2 to the 6th power. Now, it's a pain in the butt, I'm going to be honest, repeating negative 2 times 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 negative 2. I don't want to write it out 6 times. So let's try to think of a faster method we can use when we're multiplying exponents that have the same base. So I want to go back to the beginning and I want to take a look. You don't have to erase what you have, but just pay attention and make sure you include this as part of your notes. If I look at this first exponent, and I look at this second exponent, and if I can relate them to this exponent over here, what could I do with the 2 and the 3 to get to the 5? Well, hopefully you're noticing that if I take 2 and I add it to 3, that gets me to 5. But there's some things that we have to look at first. First of all, there has to be the same base for this to work. And in this situation, the base is 2. So our base did remain the same for both exponents. Second of all, let's look at our exponents. Is 2 plus 3 5? Well, it is. So it works for this one. So if I'm multiplying exponents that have the same base, it looks like I can add my exponents and keep the base. So let's see if it works for the next one. First of all, I have to look at my bases. Are they the same? Yes, they are. So now I can apply my rule. Here's my exponent of 2, and if I add that to this exponent of 2, do I get this single exponent of 4? And yes, you do. 2 plus 2 is 4. So when I multiply exponents that have the same base, I add my exponents and keep the base. Let's finally look at this one. This got erased because I erased it. And that answer was negative 2 to the 6th power. So let's see if the rule works for this one. Our bases are negative 2, so that's awesome. My exponent is a 2 here. My exponent is a 4 here. If I take 2 and I add it to 4, what do I get? Woohoo! I get a 6. It totally works. So remember, my rule is when I multiply exponents that have the same base, you can add, oh yeah, this is some neat handwriting coming your way, the exponents, and please just write this down as I do, and I'm going to abbreviate exponents. If you want to, you can as well, and keep, oh gosh, that's terrible, the base, and base, A-S-E, yay, I wrote it. So when multiplying exponents that have the same base, you add the exponents and keep the base. That is the rule for multiplying exponents. Let's take a look at dividing. We're going to do the same thing with this chart. First thing we're going to do is write them out as repeated factors. Then we're going to go ahead and we are going to write them as a single exponent. So don't forget, this 5 tells us how many times to multiply 2 times itself. This 3 tells us how many times to multiply 2 times itself. And this bar means division. So let's go ahead and write that out as repeated factors. That's what it will look like. So we have 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. But the answer has to be written as a single exponent. First thing we have to look at is that we're dividing. Anytime we divide a number by itself, it gives us a fancy form of 1. 2 divided by 2 is 1. Well, I can do that here too. 2 divided by 2 is 1. 2 divided by 2 is 1. Now, what do I have left with on the top? Well, it looks like I'm multiplying 2 by itself 2 times. So I can write that as 2 to the second power. If you want to keep it as a fraction, you can, because no matter what, there's always a 1 that stays on the bottom. Even if nothing else is there, there's always a 1 there. But if I'm going to write it as a single exponent, I should know that 2 to the second power divided by 1 is 2 to the second power, because anything divided by 1 is itself. And if I bring that up, bam, it matches. I'm so excited. Let's do the same thing to the next one. My exponent is 4 here, tells me to multiply 3 times itself 4 times. My exponent is 3 here, tells me to multiply 3 times itself 3 times. So if I'm going to go ahead and write that out as repeated factors, it's going to look like this. I'm then going to find my fancy forms of 1. 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. Oh my gosh, well I still have a 1 down here. If you want to write it as a fraction, you can. My base is 1, my base is 3 because that's what I was multiplying by itself over and over. So there's my base. But how many times can I multiply the 3 times itself? I only see 1 3 there. So guess what my exponent is? It's a 1. You only have a 3 there one time. There it is. And if you want, you can keep that over 1, but it says to write it as a single exponent. 3 to the first power divided by 1 is 3 to the first power. Now listen, we all know 3 to the first power is 3, but as soon as the directions say to write it as a single exponent, you have to put the exponent, or guess what? You don't get it right. Let's look at this next one. The 5 tells us to rewrite the negative 2 5 times. So we have negative 2 times negative 2 times negative 2. And please make sure yours is nice and neat so you can read it. Times negative 2 times negative 2. And we are going to divide that, bam, by, this 2 tells us to multiply negative 2 times itself twice. So negative 2. And don't forget your parentheses. It keeps the negative and the 2 together at all times. There we go. That's written out in repeated factors. Now we're going to go ahead and find our fancy forms of 1. Negative 2 divided by negative 2 is a fancy form of 1. Negative 2 divided by negative 2 is a fancy form of 1. Oh, look at this. What is being repeatedly multiplied by itself? Negative 2. That's my base. Beautiful. How many times is it being multiplied by itself that I have left? 1, 2, 3. So my exponent is a 3. Now, I can continue to put it over 1. If you want to, you can go ahead and do that. But if I'm writing that as a single exponent, I know that it just means, because anything divided by 1 is itself, negative 2 to the third power. Once again, Holy moly, that was a lot of work writing that whole thing out. I don't want to keep writing that out. It's a pain in my, it's a pain. So I don't want to do that. So let's see what I can do. Let's erase and find a faster method. I love it. All right. This was our first answer, 2 to the second power. Let's go back here and look at our exponents. We have a 5 and a 3. Our bases are the same. They're both a 2. And that's what we had to have when we multiplied. We had to have the same base. So far it looks pretty similar, except for now I'm dividing. Well, how do I connect a 5 and a 3 over here to my exponent of 2 over here? Well, hopefully what you're noticing is if I take 5 and I subtract 3, I get 2. Ooh, and my base stayed the same. It's very similar to multiplication, except for now in division, I'm subtracting the exponents and keeping the base. Well, let's see if that works. Okay, let's just see. We had a 3 to the 1 over there as our answer. So let's go back here to our original exponents. We have a 4 and we have a 3. Our bases are the same. Awesome. So if we divide exponents that have the same base, we subtract our exponents and keep the base. What is 4 minus 3? Well, guess what? It's 1. Bam! That one works. I'm so excited. Woohoo! Let's see about the last one. Try to remember on this one, I know we erased it. Our answer was -2 to the third power. You should still have that on your chart. Well, let's apply this rule. I have an exponent here of 5. I have an exponent of here of 2. My bases are the same, which is a -2. 5 minus 2, because when I divide exponents that have the same base, I subtract my exponents and keep the base. And there it is. 5 minus 2 is 3. So when we divide exponents that have the same base, we can subtract. I'm going to go ahead and abbreviate our exponents, or the exponents, and keep the base. I'm going to tell you one quick remembering point. All right, there it is. Write that out neater than me. Okay, write that out neater than me. So when we divide exponents that have the same base, we subtract our exponents and keep the base. That's the most important rule to remember. How do I figure out multiplication versus division? Well, try to remember, when you multiply numbers, they get bigger. So when what other operation makes numbers bigger? Well, addition does. So when we multiply exponents that have the same base, we add the exponents and keep the base. Well, let's think about division. Division makes numbers smaller. What other operation makes numbers smaller? Well, subtraction does. So when we divide exponents that have the same base, we subtract our exponents and keep the base. Hopefully you'll keep these rules straight in our practices and our stations today. Good luck with that. And if you have any questions, let us know. Thanks so much.